Welcome to this new video about my two plugins. If you are new to my channel, the plugins allow you to control your simulation with the StreamDeck, and you can display data from the simulation on your StreamDeck. Be sure to check out the installation video from this playlist. After a long time of development, two new extremely powerful features are now available. The SimHub plugin version 1.11 includes the new Computed Properties feature. This allows you to create new SimHub properties with values derived from existing SimHub properties. This is done using custom JavaScript code, making it extremely flexible. These computed properties can be used in all places where normal SimHub properties can be used. For example in dashboards, but of course also for being displayed on the StreamDeck. The StreamDeck plugin version 2.0 contains the new generic button. This generic button is a huge milestone in the development of the plugin. It can display any number of states, be parameterized very flexibly with encalc formulas, and send commands to your simulation or SimHub depending on properties and complex conditions. In this video I won't go into the basic usage of the new features. They are documented on the respective project pages. The links to the documentation are below in the video description. Instead, I will show a few practical examples using Euro Truck Simulator 2. However, this video is also interesting for sim racers, as the concepts can be applied to all simulations. Before we dive into the examples, let's take a quick look at what I've configured on my StreamDeck. At the top left, I have a combined turn signal indicator, which you could already see in the video. The current speed limit is displayed directly below it. On the rotary knobs, I have cruise control, the retarder, and the windshield wipers, whereby the windshield wipers use a computed property to display the wiper stage, which was also visible in the video. Furthermore, there are two keys that show the sleep or rest timer, as well as the remaining time to the destination. Fuel and job are somewhat more complicated, as they also use computed properties. Fuel displays the range and, from a computed property, how much time remains at the current speed until the tank is empty. Job displays how much time is still available for the current job. In addition, a computed property calculates how much buffer time will be available at the end, taking into account driving and rest times. In the current example, I can drive for another 9 hours, then have to rest for 9 hours, and then drive for 5 hours to arrive at the destination. Consequently, I will be on the road for another 23 hours. I still have 28 hours left for my job, so I have a buffer of 5 hours in which I can do sightseeing or discover new roads, for example. In this video, I show how to configure the display of the turn signals, the speed limit, the rest or sleep timer, and I also show how to display the time that the fuel will last depending on the current speed. I am planning a follow-up video that will cover more complex topics, such as displaying the job buffer time, the windshield wiper stage, and whether a truck or trailer has liftable wheels, which all make use of computed properties. Time for some examples. The first one is a very simple one. I want to display the turn indicator on my StreamDeck. So I drag the new generic button into its position. That will be our turn indicator. And we want to display an image. Let's take this green arrow And we have to find the corresponding property in SimHub. Turn indicator left. Now let's observe the values of this property. It's alternating between 0 and 1. That's perfect for us. So we need a condition when we want to display this turn indicator. Now it's always on, but we want to bind it to this property, and it shall be visible if its value is larger than 0. Now we have a nice turn indicator. If you want to control the turn indicator, in my example I'm using the SimHub control mapper, so I would have to bind a role, and for me it would be the indicator left. Now I could also control the turn indicator from my StreamDeck. But in this case I'm controlling it from my controller, and I just want to display the state of the turn indicator. And it would be a little bit waste of StreamDeck keys if I would use 2 different StreamDeck keys just for visualization. So now we jump into the power of the new generic button. Let's remove this one. Indicator on. Let's make this one a little bit smaller, like 90 by 90. And move it a little bit to the left, down. Now it's centered on the left, and we can add a second image, this time the turn indicator to the right. We want to bind this one to the turn indicator right property. Same thing, we have to make it smaller. Now we cannot see this turn indicator right because it's not active. In this case you could just, for example, use true, or now we can see temporarily the right turn indicator all the time. Move it down to the same position, that's 27, and a little bit to the right. Okay, that looks nice. Now let's remove this tweak. And that's a combined turn indicator on a single StreamDeck key. We can make it a little bit more fancy because now it's completely dark. Let's add another image. We move it somewhere here. We use again the turn indicator left. And this will be our turn indicator when it is off. Turn indicator left off. Give it a transparency of 40% or visibility of 40%. We apply the same translation. That was minus 1027. Size was 90 by 90. Let's make it. So this one is our turn indicator off, and we want to show it if our left indicator is off. The same for the right. off. Same translation here. That was 27 and plus 60. Make it only partly visible, and we want to show it if the right turn indicator is off. Okay, now we have dimmed turn indicators when they are not active. When they are active, we have those nice flashing turn indicators on our StreamDeck. The next example, I want to show the currently active speed limit on my StreamDeck. So add another generic button. Currently there's no speed limit active because we are parked. So we start with the icon for no speed limit. That's our, give it a name, speed limit, so that we can identify it easier. We want to add an image. That's this one. Now we have to find out the speed limit. There's the speed limit in kilometers per hour. That's what I want to have. It is 0, so I assume that it will have a value if the speed limit is active, and it has the value of 0 if there is no speed limit. So we take this one, and we want to show this no restriction if it has a value of 0. Now we have to move our truck somewhere where we do have a speed limit. Here we are, and maybe you've seen already in the background this property changed to 50 because we have a speed limit of 50 kilometers per hour. So we have to add another image, this time the one for our restriction, and it shall be visible if this property has a value larger than 0. What's missing now is the number on this icon, so let's add a value, and we want to display the value of this property. Now you don't see anything. Let's change it to black. Here's our speed limit of 50 kilometers per hour. You can make it a little bit larger. That's, for example, 26. And we have our nice speed limit. In this example, you can see that the order is important because the elements are drawn from top to bottom. If their conditions are met, they are drawn. So this one is not being drawn because condition is not true, but this one is drawn, and then this. If we change the position, you can see that the number disappears because now the number is being drawn, and right afterwards the sign is being drawn on the number. So in this case the order is important. Now the number appears again on our sign. So let's test if it's still working if we return to our garage. Oh, there's a problem. Want to show the value only if we have a speed limit active. Perfect. Now we have our speed limit on our StreamDeck. The next example is a little bit more complicated. I want to display the time that rests until I have to sleep. So that's our rest or sleep timer. Let's start again with a generic button. And we have to find the property for our rest timer. Next rest stop in minutes. That's in 404 minutes. So we could display a value that would be our sleep or our rest timer, and we want to display this property. We have to sleep in 403 minutes. Now I would like to have this value in hours and minutes. Move this one away, and sometimes it's good to have a test button where we just can play around with our values. Now, for example, if we have rest timer of, let's say, 91 minutes, how can we get those two parts, hours and minutes? Now, for the first part, for the hours, we have to divide it by 60. That gives quite a long number. So we have to check what we can do in order to get just the first part here, the 1. If you check the documentation of the generic button, then you can find here a section about the expressions, and here you can find links to the NCalc documentation. We want to get to the functions. So there's ceiling, that's not the one we are looking for. There's floor, we could use floor. That means we will have from our 91 minutes, that means this part of 1 hour. I already know, because I observed, that this value can get negative if you missed your sleep. So if I use minus 91, it shows us minus 2 hours, which is not correct. And if you look into the documentation of floor, that's always the largest integer less than or equal, and it also applies to negative numbers. So we have to find a different function, and further below we can find truncate, so we get just the integral part of a number. Let's try this one, truncate, and now we have minus 1 hour, and in a positive case plus 1 hour. That's our first value. Now we have to extract the minutes. The minutes, that's an easy operation. That's the module operation, which is written like this. And we have our 31 minutes. That's basically all we need to display the rest or sleep timer. We just have to combine these two numbers. You could do some string operations here, but there's also another powerful function that I added. It is the format function. Format function takes a format string and the parameters. There's some documentation how it has to be written, and links to the Microsoft documentation how composite formatting is being done. Format string and the parameters. So of course one parameter would be our calculation for the hour. And the second parameter would be our minutes. Let's put that into the format function. We will have the format here. And we close the parentheses here. Now for the format. Here's an example. Parameters are numbered from 0. So we have parameter 0 and parameter 1. And then we have to supply the information how we would like to format. In this example, there's a decimal format and a fixed number or floating point format. So if we try the first one, that was parameter, the first parameter I want to display, that could be a decimal number. And the second, here's our colon between hour and minute. The second parameter, that would be also 2 digits. Now you can see that our format specifier is invalid. This is caused by how ncalc works internally. Ncalc uses floating point numbers for every result. So even if the result of this truncate operation is an integer number, ncalc still handles it as a floating point number. Floating point numbers cannot be formatted as a decimal number. So we have to use floating point here. Of course, without decimal places. So we have our first value. The hours formatted as floating point number with 0 decimal places. That's correct. And we also have our minutes formatted as a decimal number with 2 places. Let's try the negative value. There we get -1 hour. But we also get negative minutes. That's not what we want to have. In the functions we can find that there's also the abs function to return the absolute value. Let's try abs function around our minutes. Now, as I've already explained, even if the abs function returns an integer number, we get now a floating point number for this result. And floating point numbers cannot be formatted as decimal numbers. If we check the standard formatting functions, here they are. That's the decimal function that we used, or decimal format specifier, and the fixed point. We could use fixed point, of course, but then we get the whole thing with decimal places. Let's remove them. That could be our rest timer if we are 91 minutes past our rest time. Let's try a different number, for example 61. That looks a little bit strange for time display. I would like to have a leading 0. So we have to format the minutes a little bit different to get the leading 0. It is still a fixed point number, but if you look here, you can see that F only supports the number of decimal digits, but not the number before the comma or point sign. So we have to go into the custom numeric formats. There you can find that there's a 0 placeholder. Let's try this one. Instead of F0, we will use 0. 0, that means display 2 digits. And if we don't have enough digits in our number, pad them with leading 0. That's exactly what we want to have. Now we have, for 61 minutes, we have 0, 1. That works also for the positive case. If we have 61 minutes left, it displays as 1 hour and 1 minute. That's basically all we need. So let's transfer this formula to our actual example. So our variable was the next rest stop time in minutes, which we have to insert here. And here. That's our rest timer. Now we know that we have 6 hours and 11 minutes before we have to sleep. Now there are several options in order to add a label. A very simple one would be like sleep and line break. Now we have it like this in the same format. If you want to have different sizes, we could move this one a little bit down, let's say down by 15 or 20, and we could add some static text. That would be rest, not the name but the text rest. And we could display it by -20, and we could use a larger font for this one, for example. That's a little bit too large. This example shows how we can combine different elements like static text and computed values. You could also add this value, you could clone it and add it a second time and, for example, give it a different color like orange or red. If your value next rest stop minutes is, for example, below 90 minutes, so you will get a visual indication which will turn red or orange if you are close to your next rest stop. In the last example, I will show you how we can use computed properties. I want to display the time that remains with the current fuel at the current speed until our tank will get empty. Let's remove this one, remove our test. So we have to find the corresponding property, and I already looked at different values, and the most important part here is to get a stable value, a value that does not change every second, so that your StreamDeck display jumps around and the value will have no meaning for you because it changes so often. So after some investigation, I found that there is the fuel value range. This is the range that is calculated by ETS2 and it's being displayed on your dashboard. Let's look if we can find it. Here we have 347 kilometers left until our tank will be empty. This value has a huge advantage. It's already dampened by the simulator, so its value is not jumping around, and that's exactly what we want to have. We just have to divide this value in kilometers divided by our current speed, and we will get the time that we can drive at the current speed. So time for our first computed property. Let's call it ETS2 fuel time remaining. We can start by just inserting the sample, which gives us already the skeleton code. We want to create a new property that's called fuel time remaining. I'm using a prefix of ETS2 in addition, so because I have several computed properties for different simulators, so with this prefix I can separate them. So that's the property that we want to create. Now we want to call our function, it's called calculate. Let's name it calculate fuel time. We want to update the value whenever the property that we've just seen changes its value. So that's not current date time. We want to insert a property, and that was full value range. As you can already see, it's 346 kilometers and it has a very high precision. That's way too precise for us. StreamDeck is not so fast. If you're driving, this value will update every few centimeters in the game world. We don't want to have such a high update frequency, so we have to do something with this value first. So let's select it and insert it. So whenever this value changes, we want to calculate the time that we will have left. So let's start by whenever this value changes, our function is being called, and we start by reading exactly this value from SimHub. Now, as I've already said, this is changing very often. So now we are in JavaScript, not in ncalc anymore. But if you remember the floor function in JavaScript, it's called math.floor. Will give us the value without decimal places. So now we have this value of 340, I think it was 347 or something like that. Now we have to get our current speed. I'm using const here because the fuel distance won't be changed anymore in this script. I'm using a variable, and soon you will see y for the current speed. Our current speed. Let's find our current speed. Okay, we are not driving, and as you can see, this one is also insane precise. Again, we have to use the floor function to get a usable value, math.floor. Now we have to make some adjustments. First of all, I don't want to be that precise. It would be fine if you would have it in increments of 5 kilometers per hour, like values of 0, 5, 10, 15, 20. I will just show you how this could be done. That's a simple function. Functions can be written with the arrow function in JavaScript. Let's remove this one. It's just throwing an arrow. Round up to 5. You can call this function, give it a number. The number is divided by 5. With the ceil function, we will get the next largest integer of this division, and then we will multiply this value by 5. That's exactly what I explained. You will get outputs of this function from 0, 5, 10, 15, 20, 25, and so on. So our speed should use this function round up to 5. And now we have speed which is more stable, which does not change so often, because otherwise our StreamDeck display would just jump around with every small acceleration or deceleration. We do not want to update our value that often. We want to have a stable value. And something else, if we are just sitting around or driving very slowly, less than 30 kilometers I've chosen, then I assume a speed of 30 kilometers. This again helps to get smoother values. Now we have our speed, we have our distance, so we can calculate the time, fuel time. That's quite easy. This distance divided by speed, and at the end we just have to update our property. We created this one, so of course we should write to this property, and we want to write our fuel time. No problems, perfect. Let's look into the properties, and here we have computed properties plugin, fuel time remaining. With our current speed, as we are just sitting around, we assume a speed of 30 kilometers per hour. We will be able to drive for another 11 hours with our tank, which has 343 liters left. Now let's display this value on our StreamDeck. As you have noticed, this time we don't have a value with minutes, but we have hours with decimal places. So we have to use a little bit different function to display this time than, for example, for our rest timer. Generic button. That's our fuel time. We want to display just a value. Now that's our fuel time remaining. $11 and 0.4 times 60 minutes are left at the current speed. How do we get these values? So the hours are really easy. We just truncate this value, and as it can never get negative, it's just fine. No arithmetic has to be done as before. We have our 11 hours, but how do we get the minutes out of this value? Well, we have to make a modulo 1 division, which removes the integral part and just gives us the decimal places. The decimal places have to be multiplied with 60. So our 0.4 means actually 24 minutes. And just as before, we just have to combine these values in our format function, which takes the format. We will fill this value in later. We have two parameters, this one for the minutes and we had this one for the hours. And our format, it's the same as, almost the same as before. Now we have two decimal numbers, so we use custom formats. The first parameter shall be formatted with at least one leading zero. Here are our 11 hours, colon, and the next parameter with two digits. So here at our current speed we will be able to drive for another 11 hours and 22 minutes. Let's make it a little bit larger. And if we start to drive around, this value will change. Okay, no accident, please. It's a little bit complicated with this small window. Let's try to be a little bit faster, and you can see our remaining time just drops down. Of course, this value makes most sense if you're using cruise control on the highway, then you get a very stable number. If you have been brave enough to watch the video up to this point, I have two more pieces of information about this last example. First, the computed properties script is available on GitHub. You can easily copy and paste it from there. Just go to doc, computed properties, examples, and here you can find the script. Second, in the script you can simply multiply the value fuel time by 60 to then use the same logic and formatting in the generic button as for the rest or sleep timer. As always, there are many ways to achieve the same goal. I hope that these examples have demonstrated the powerful possibilities of computed properties and the generic button. Until next time.